Let's solve the final exam 6 questions, 1 video per question. This is question number 1 of 6. In the circuit below, this one, with the switch closed, this switch, determine the Thevenin equivalent circuit seen by the capacitor, by this capacitor, using the 1 amp, 2 amp method. Be sure to write the complete set of MNA equations necessary for this case so that the marker can assess your MNA, even if your final answer is incorrect. In that case, you don't get full marks, but at least you get some marks. I'll read part B later. The first thing I'll do is replace all those symbols with the numerical values provided. This way. Well, the observer of this circuit is going to be the capacitor, so the capacitor is the first thing I remove and replace that with a 1 amp current source. This way. What I need to compute is this voltage, V1A. I will use MNA, no surprise there. This is my reference node, my choice and convenience. All of this will be node number 1, and then node number 2. You can number them any way you want. This is node number 3. This could be node number 4. Some of you may have done that, and that is at least not wrong. But in this case, I'm going to take advantage of this V source, in which I am not interested in finding the current. I would say, well, this is the reference. The voltage source is 10 volts. The voltage here in this node is already known, 10 volts. I'm going to write 10 volts there. I will not compute this evil current. Alright, so let me see if there is any evil current that I need to highlight. Well, the one here, no, I'm not computing that. The one here, okay, this is evil current. Let me write that. Evil current, good. And next, what are the branch currents? And that is arbitrary, as we will know. This way, we are ready to write the MNA equations. Well, controlling equations, sure, there is one controlling variable, Ix. I need one controlling equation for that one. Kcl. That is Ix as a function of V voltages. Here is Ix. That is V3 minus V2 over 20. And then let's find evil equations. I'm not writing one for this one because I'm not interested in the current in this evil branch, and I'm already using the voltage of this node, so I have only one evil equation, this one, and I'm writing that. If you wrote 2 evil equations, that is right as well, no problem, it's only more work. In this case, the evil branch says that this node, the positive one, 10 volts, is equal to the low one, V2, plus the value of, that 2 doesn't look like a 2. Let me clarify that, lest I make a mistake typing that in the calculator. The value of the source is 7 times Ix. Excellent. And then the 3 Kcl equations. Let me accelerate them. This is Kcl for node 1. This current at the top, entering node 1, V3 minus V1 over 20, plus this current here, which is V2 minus V1 over 20, plus the very important 1 amp current source. We have to keep an eye on this equation. And that is equal to currents leaving the node, those two, V1 over 20 plus V1 over 20. Let me write now Kcl for nodes 2 and 3. Currents entering node number 2, this one, IEV, the evil current, plus 7 amps, plus the current coming from the top, V3 minus V2 over 20. And that is equal to currents leaving the node, in this case, only one, V2 minus V1 over 20. And we go for Kcl3. Currents entering node number 3, only one the way we drew them, this one, 10 minus V3 over 20. And that is equal to this current. You can write that as V3 over V3 minus V2 over 20, or just Ix. Ix is one of the unknowns. I'm going to write that to simplify my writing, plus this current, which is V3 minus V1 over 20 ohms, the one on the right, and we're ready to enter them in the calculator and solve for V1, V2, V3, Eve, and Ix. I care only for V1, which is V1a for the Thevenin method. I will spare you the entering the data in the calculator. You've seen me in doing this like a million times only. The solution to this one gives me V1 is 10 volts and V1 is V1a. Now to find V2a, you know what to do. We replace this current source with a 2 amp current source, and we find this voltage again, and now we call that V2a, but it's still V1. Good. In the equations that we still have in the memory of the calculator, we only replace this 1 with the 2, press the solve key again to find V2a. Again, that is a new V1. This 2 looks a bit confusing. V2a, V1, and this value was 1350 in my calculator, divided by 89. This is not a final value, but just so the marker can compare that with his own results, I'm going to write that as a decimal expansion. That is V2a, 15.17 volts, and you know what to do now. You just solve the 1112 system of equations. This system of equations, 1112, with V1a and V2a over here, and the solutions are V Thevenin 4.83 volts and R Thevenin 5.17 ohms. But part of your answer is drawing that equivalent circuit, and that is what I'm going to do. As 5.17 and 4.83 volts. And that is part A. What about part B? Let's see. Let's go back here and read that carefully. With the switch open, determine the Thevenin equivalent circuit seen by the capacitor. Oh, so this is disconnected. The capacitor that was here, remember? Let's bring it back. Like this one. So there was a capacitor in here, right? Somewhere in here there was a capacitor. We have to discover that. Where is it? It's there. Somewhere. There is the capacitor. But now this switch is open. Well, let's open that. In opening all the circuit to the left of the switch. So this is the situation. With that switch open, the rest of the circuit has disappeared from the vision of the capacitor. The capacitor sees only that 20 ohm resistor. The question is, for part B, with the switch open, yes, we did open it, determine the Thevenin equivalent circuit seen by the capacitor. Use your common EECE in lieu of a 1 amp to 1 method for this part, and don't forget to draw it too. Well, this was the freebie of this question, if I may, because evidently what is the Thevenin equivalent seen by the capacitor? It's just a resistor. So that means that the Thevenin equivalent seen is V Thevenin 0 volts, and our Thevenin, guess what? 20 ohms. And the circuit's already drawn. That was free. It was a freebie. Anyway, this is the end of question 1. Thank you very much.